In this video, we will set up the build tool to create our final library file. To understand what will be created, we first need to talk about the different type of bundles a bundler can create. JavaScript libraries can run in different environments. They can be made to run on the web, for old browsers, for new browsers, and they can be made to run on Node.js, old and new versions. For our library, we're going to use Rollup as our module bundler. There are a lot of module bundlers out there, including Webpack. Vite can be used as a module bundler. What a module bundler is, the aim is to bundle your source code from an entry point to an endpoint file, and in the process, making some transformation. In our situation, we are going to have an index.ts file as an entry point. All of our files are imported from this file onwards. Rollup will apply the transformation necessary, such as TypeScript transpilation via plugins. As mentioned previously, JavaScript can run in different environments. It also has a vast, chaotic history that translates in multiple formats to create a bundle. The first format to talk about is immediately invoked function expression, also called IIFE. You can use an immediately invoked function expression to create a module for the web. The main benefit of an immediately invoked function expression is that you will encapsulate all of your code in a function. An IIFE will allow you to not pollute the window object. So here we're going to go to rollup.js website, and you're going to be able to see exactly what every format looks like once it's compiled. And it's going to be a really good way for us to compare the different formats. So if we take a look at the website, and let's take an example. So that's going to be our example. And if we take a look at the formats that are on the right, we can see ES, EMD, CJS, and this is the one we want, IIFE. So here, IIFE, we can see the immediately invoked function expression right there. And so in our example, we have a pi variable that we used in our code, but we don't want it to be available outside my bundle. Having it available outside of the function in the window object will also make it a potential collision with other parts of an application or another library that could use the same name for the variable. And that's the benefit of an immediately invoked function expression, because every variable is going to be scoped to this function, and so you can reuse pi in another library that will call by a different name, and that's not going to have any problem. So now let's talk about CommonJS, which is here referred as CJS. CommonJS is commonly used for Node.js module. A Node.js file is in itself a module. Its local variables will stay local, and you will need to require the function and properties another file has exported. If you require another function from another NPM module, it will translate to the same require module, which would not work on the web. As an example, we can add a no-op import from a Node module, and you can see that here it just translated with var module1 equal require module1. Require is not defined on the web, so it's not going to work. So it's really, CommonJS is mostly used for Node.js. Quick note about this format is that all of the imports will essentially be grouped in the same file. If two functions have the same name, the bundler will be smart about it and just rename one and use the new name of the function in the code. And now that we have a good understanding of what an immediately invoked function expression is and what CommonJS is, we can take a look at UMD. And UMD stands for Universal Module Definition. When you create a module, the main difference between the environment is the exports method. For the web, you want to expose the exports in the global, which is the window object. For Node.js, you want to expose the exports via the exports object. UMD is essentially wrapping the code in an immediately invoked function expression that takes a factory function as an argument. Then again, we can take a look here at our example and see it in action. So we got a function with a global and a factory as argument. So what is happening is the factory function is the one that contains your code. It is called with the exports object, which is determined programmatically. In the code, in our example, we checked which exports to use. If define is defined, we can use the AMD loader. AMD is actually another module definition that we are not going to talk about here. If the exports object exists, we are in a Node.js environment and can use it. Otherwise, we are in a web environment and we are going to populate the global object. And now we have ES modules. ES modules are the modern way of writing JavaScript. If you have written JavaScript in the past few years, you are most likely familiar with the import-export syntax. Those modules can be used natively on the web if you're using evergreen browsers, and Node.js also worked on a native solution to run them, so the new versions are able actually to run them. ES modules are slowly becoming a more cohesive way of creating modules in JavaScript. This is prompting module bundlers to innovate with ES modules. Snowpack and Vite are two module bundlers that are taking advantage of the compatibility of ES modules on the web to provide a fast development experience. Now that we understand the different formats to create module with JavaScript, we can choose the ones we want for our project. If you want to create a bundle for the web, you can add an immediately invoked function expression exports for older browsers. We will not use it in this configuration because we only want to target Node.js. Because we are using TypeScript, we're going to use the Rollup plugin for TypeScript, which is rollup/plugin TypeScript. We are also creating the types for our library. The types for the library are created with the same name as the output file we specified, with the d.ts extension. The configuration that I'm showing below is kept minimal. It creates two build files, one for ES module and one for CommonJS. It uses two plugins. The first one is the Rollup plugin for TypeScript to transpile our code from TypeScript to JavaScript. And the second one is Rollup plugin Terser, which is used to minimize our code. So we can just install our dependencies. And once our dependencies are installed, one thing that we need to remain is modify the package.json file. Main is for the library entry points and will correspond to our CommonJS file. The module property was used before in the package.json to specify the ES module file. We can still specify the module property here, but we can also use the exports property in the package.json. The export property allows you to specify which file is going to be needed if you're using require, which file is going to be needed if you're using imports, and which one for the types. In our situation, we're going to point one file for the production version and a different one for development version. What we want to do is create conditional build because many libraries provide a development version and a production version. Both of those versions are created from the same code base. You might want to create a development version to provide debugging features to your library, add logging messages, for example, and those features are unnecessary for the production version of your library. They will only increase the size of the library. To create conditional build, you just need to add a constant that you can call development, for example, and the build tool will be responsible for replacing this variable with a value, true or false. Rollup will optimize the code with dead code elimination. It means that when the code encounters a condition such as if true, else, do something else, it will remove the part of the condition that will never happen. TypeScript will warn you about the unknown variable development. So we need to declare the constant in our project. In this case, it's in source types global.d.ts. We just have to write declare const development boolean. Rollup as a plugin to modify the value of a variable at build time. We need to install it and use it in a configuration to set development to false and true. Rollup configuration files can take an array if we need to create multiple configurations. The configuration below has both the development and production version. And that concludes the Rollup configuration for our library. Next, we will set up continuous integration with GitHub Actions.